Welcome to the session on engineering graphics. In part 1 we had seen how to draw the projections of the hexagonal pyramid, which is cut by a cutting plane which is perpendicular to VP and inclined at 40 degrees to HP. Also cutting the axis at a distance of 25 from the apex. So we have also marked the cutting points and all. So here we are going to see how to develop the remaining portion of the pyramid. So to do that, first we have to know one of the slant edge true length. We know it here, that is 67.008. So with respect to this, we have to draw one line having this length, that is 67.08. Enter it. Just you have to get the line, and you can name this line as OA. So this point is O and this is A. So this line is representing the true length of edge OA. So similarly we have to get all the edges true length. So to do that, say I will be taking the arc from this point. So just have the little adjustment here. So from this point to this, here radius is 67.08. so this is the arc what I am going to draw. So approximately this much arc I will draw. So now we have to get BO, CO, DO and so on. So to get them, you have to go by arc by center point. So from this point you have to get the arc of radius 30, as AB is 30 here, AB is 30. So from this point I will be getting this arc, and I will be connecting this end to this point 30, and I connect it back here. So now you have got this triangle. This triangle is one of the slant triangular face of hexagonal pyramid, having a side, if we name the side here, this is 30, and the side edge of the triangle is 67.80. This will also remain the same, that is 67.80. So you have got one triangle here, so you don't have to draw the remaining triangle, just you can move them according to the requirement, or you can also go for the mirror option. It is better to move, so I'll go for move command, I'll go for rotate command. So this triangle I have to rotate. So I'll select this as a rotation point. Still I have selected the move command, so I'll go for the rotate command. Okay, so this I have to rotate it. So to rotate, I need a copy of this. From here to here I have to rotate, then I have to rotate, I have to rotate, I have to rotate, I have to rotate. So tip 6 faces I get tip that I have to rotate. So I have rotated, and I have got the 1, 2, 3, 4, 5, 6 triangular faces. So now I can name them as this point as C, this is D, this is E, this is F, and this is back to E. So we have AO to AO, and in between we have got the other points, that is B, C, D, E, F. So now we have got the 6 triangular faces, and we have got the 6 cutting points on the edges of these triangles. So AO we have got 1. So we'll find out the distance of 1. Okay, so distance of 1 is this much, that is 48.15. Then distance of 2 and 6 is like, say, distance of 4 will take this much. Then distance of 3 and 5. 3 and 5 will be getting this much, and 2 and 6 will be getting this much. Okay, so distance of 1 is 48.15, distance of 2 and 6 is 35.37, distance of 3 and 5 it is 23.1, and distance of 4 is 19.69 from O. So now we start with the point 1, arc by center point. So you get this arc on this edge, that is distance is 48.15. Enter it. from this point to this area. Okay, so you'll be getting 2 points. So mark this 1 point here, and this is also 1 point here. So now the second point we have at a distance of 35.37. So from this 35.37 enter from BO till FO. So you will be getting this as 0.2 and this as 0.6, 2 and 6. So now 3 and 5 you have got a distance of 23.1. So this is from CO 23.1 enter. So from here till here, so you will be getting 0.3 and 0.5. Then the distance of 0.4 is 19.69. So from here you can have the arc here 19.69. Enter, and you can get the arc here, small arc, and you can name this point as 0.4. So now you have all the 6 cutting points on all the 6 edges. You have to connect them using thick line. So go to line, select the line 0.4 thick, then from this 1 point to 2 point to 3 to 4, 5, 6, 1, then you connect to A, F, E, D, C, B, A and back to A. So you have got the sheet size. Now you have to fold this sheet at this 2 to B, then 3 to C, then 4 to D, then 5 to E, then 6 to F, and then you have to connect A1 to A1, and if you fold it at these lines you will be getting the hexagonal pyramid, which is cut by a cutting plane having inclination of 40 degrees with respect to H1. So this would be the development of the hexagonal pyramid using software. At the end you can also trim the extra lines which you don't want. It is optional, you can trim it or you can retain them as thin lines. So like this you will be having the development of the hexagonal pyramid. So same thing applies to all the pyramids. So in some of the cases you will be having true length of any of the slant edges. Means you will not be having the true length of any of the slant edges when this hexagon is resting on the edges. So that time you have to do the alternate arrangement to get the true length, and you have to complete the development. So this completes the development of hexagonal pyramid using software. Thank you.